All right. Hello, everyone. We are here today for the How to Go from Continuous Integration to Continuous Delivery webinar. This is being hosted by CloudBees, and we have a guest speaker from Forrester today. We are recording this session, and we'll be making the recording and these slides available to everyone in just a few days. Our CloudBees speaker will be Dan Junks today. Dan is a Senior Director of Product at CloudBees, where he leads the go-to-market strategy for the CloudBees continuous delivery platform powered by Jenkins. He has 20 plus years, of high-tech experience in areas such as grid computing, high performance and computing, application performance. He has worked as a customer and vendor at both startups and enterprises, and he has held senior technical positions at Red Hat, Sun Microsystems, SGI, Wiley Technology, and Terracotta, and he started his career at Lockheed Martin, where he computed hypersonic reacting airflows around Mach 30 flight vehicles. Our first speaker will be our guest speaker from Forrester, Kirk Bittner, who is a principal analyst serving application development and delivery professionals. He has had a long and varied career where he has been developer, application architect, database application performance tuning expert, product manager, a catalyst for improving application development capability, a coach and mentor, and a business unit manager. His research focuses on helping organizations improve their speed and quality of delivery while reducing costs and improving business performance, which is what we will be talking about today. And so without further ado, I would like to pass it over to our guest speaker, Kirk Bittner. Oh, Kurt, you're on mute there.
Thanks very much for the introduction, and without further ado, we will get into our presentation. Let's see if I've got control over the presentation yet. There we go. Okay, usually I meet a lot with executives, and the question comes up, usually, why continuous delivery? What they know is that they have to compete faster, they have to deliver applications faster, and so this increasing intense competition is coming from consumers largely who, armed with mobile devices, armed with cloud applications, have lots of these rich experiences, and if organizations aren't delivering those same rich experiences that their competitors are, they're losing those customers. So it was brought to a point a couple of months ago. I was having a dinner with a bunch of CIOs from various banks, and they looked around at each other and they said that they didn't regard each other as competition, and everyone nodded at that. They said that they felt that their competition were people like PayPal, Google, Apple, and so this revolution in mobile devices is really rippling throughout the different markets and different industries, and it's forcing everybody to reconsider how they deliver software. So that leads us into this continuous delivery and the need for continuous delivery. And this is just, it's really become a top-level agenda of almost every CIO. One of the ways to think about this is that you can think about a delivery cycle that starts with customer experience. You gather feedback, you get satisfaction gap information from that feedback, so you find out where the customers are happy or unhappy, what kinds of things they would like additionally. You come up with new ideas, you create the solutions and deliver those back to customers, and then that cycle begins again. Well, what we found in our research is that faster release cycles result in less risk because the releases are smaller and they have fewer dependencies, but also less waste because you spend less time building things that the customers don't really care about. And so that the combination of less risk and less waste results in lower cost. Customers are also happier. And so that tends to drive much better business results. And we've seen this across a wide variety of different surveys. The other way to think about this, though, is that if we look at across a variety of industries, the releases are still relatively infrequent. So we see the mean in this distribution is about once per quarter, or the most frequently occurring is once per quarter. The mean is actually shifted to the right of that. So once per quarter, twice a year, once a year or less, et cetera, still dominates the delivery cycle when we look across all different kinds of applications. Now, there are a few organizations delivering many times per day, some delivering once a day, some delivering once a week and once a month. So we consider really anything that's faster or as fast or faster than once a month is actually relatively fast in the current market when we look across all different kinds of applications. So that's what's driving this need for faster delivery. It's not just faster delivery of mobile applications or cloud applications or SaaS applications. It's faster delivery across the entire spectrum of applications, including the systems of record. So there are a variety of challenges that arise from doing that, and part of it is the complexity of the tool chain itself. So we did an analysis earlier this year where we broke apart the continuous delivery pipeline, and we looked at the different kinds of tools that were used in that pipeline. And one of the things that came out of that, you see a couple of things that I've highlighted here in the blue text. Continuous integration is pretty widely adopted, still going through a lot of growth. Most organizations have some use of continuous integration, but it's not even that isn't universal across organizations. But something we call continuous delivery management, the management of the entire pipeline, is a relatively new technology. Build automation's been around for quite a while, and that's more mature. So we see that these things like continuous delivery management or managing the overall continuous delivery pipeline being a real growth area that most organizations are looking to expand. And so what we wanted to talk about today is how this continuous integration trend in adoption is migrating towards a management of the overall pipeline, including the orchestration of all these other different tools that you see in this chart. So in terms of continuous delivery adoption, it is widely adopted, but it's by no means universal. So when we look at CI, about 43% of organizations reported using CI in our global BT developer survey. But sometimes that is really just, they're doing integration multiple times a day or once a day and once a week. So there's still a big opportunity to just expand continuous integration itself. But what we're going to talk about today is how do you expand continuous integration and turn it into an overall delivery pipeline. As you do that, as you take continuous integration and try to expand it to cover the entire pipeline, there are a number of, we can think of these as speed bumps in the road or a number of obstacles that have to get removed. And so what we'll talk about is look at this from the perspective of three different perspectives. There's certainly a technology aspect to this. Automation is really key to making the delivery pipeline work, but there's also some process changes. And of course, many organizations who are far enough down this journey to give us some feedback say that the people and the cultural changes are also really important. So we have to attack all three of these. Now, one way of thinking about this is that continuous delivery is a relatively significant change in the way that organizations work. It's not just a bottom-up engineering kind of activity. It really affects and changes the way that you think about engaging with the business and the way that you think about engaging with the customers. It cuts across various organizational silos, and we'll talk more about that later. But the reason for sort of highlighting this at the beginning is that this change usually starts when some line of business executive or some IT leader says, in order to be competitive, we have to deliver faster. It's not just something where the teams themselves say, let's improve our delivery, and of course that's certainly a factor. But the organizational implications of this mean that usually there has to be some drive from the top or a competitive threat from the outside. And that's what's really driving the adoption of continuous delivery. It's a sort of threat from the outside combined with some leadership vision inside the organization. So one of the techniques and the main technique that I tend to use when I work with clients is to look at this using some of the things that we learned from lean manufacturing. And so one of those techniques is lean value stream mapping. And basically lean value stream mapping gives you a way to think about your delivery process as a pipeline that starts with the creation or the identification of some idea that you have and ends with the customer getting value. So I've illustrated this concept really just using a very simplified model. In reality, this would probably be hundreds of steps in lots of different parts of the organization. But to illustrate the concept behind lean value stream mapping, what you do with a value stream map is that you start, again, with an idea and then with customer value, and you look at all of the activities that you have to perform in order to take that idea, all the way through. You have to, understand what the needs are, define the solution, develop the solution, test it, deliver it into production, and then manage it in production, and then you gather feedback from that. Well, what I've shown here is that there are two kinds of information you look at in this value stream map. One of them is how long does each activity take? And then the second number in the blue numbers here shows how long do you spend waiting before the next activity begins. And for many organizations, especially large ones that have lots of organizational silos and lots of roles that have to get involved, that wait time can actually exceed the amount of useful work time that gets done. And sometimes it's by a factor of 2 to 1. So it wasn't unusual for us to find that 60 or 70% of the time that organizations were spent waiting for things to do. And the larger the organization, the more likely this is to be true. So this example that I've shown here, I've cooked the numbers a little bit to illustrate that, but it's fairly representative of many organizations. You spend time waiting for environments, you spend time waiting for decisions, you spend time waiting for things to be deployed. And what continuous delivery does is it tries to remove those bottlenecks as much as possible and automate as much of that pipeline as possible. We're going to talk about how to go through that now. So the typical software delivery bottlenecks that organizations see tend to fall into some broad categories. And so I've mapped them onto the simplified delivery pipeline that I showed earlier and expanded it a little bit. So when you have an idea, one of the big problems that you have is you don't have a lot of effective customer insight. It might take you a while to get that. You might have to run focus groups, you might have to run surveys, you might have to find the right subject matter experts. So getting effective customer insight introduces wait time and delays. When you understand needs and design solutions, one of the problems that organizations face is that they try to do too much at once, and that creates kind of clogs and bottlenecks in the system. In addition, when you do build integration, you've got these manual build processes. So when somebody has to physically go run a script as opposed to having it kicked off automatically when code's delivered into the repository, that potentially introduces wait. Waiting for build and test environments also introduces wait. Manual testing introduces waiting. Lack of effective decision data makes it more difficult because you've got to pull lots of people together into a meeting to make a release decision. And then manually managing environments in production adds to delays. In addition, there's lots of deployments happening all throughout this pipeline. So every time you move things from a build environment to a test environment or between stage test environments or from a final staging environment into production, you've got a deployment process. And when that's manual, that introduces delays. It also introduces possibility for errors. There's lots of, when you have more roles in the system or more roles in the process, then you've got lots of handoffs and lots of wait time there. And then back to that inadequate customer feedback or lack of effective customer insight. When you take a long time in this process, you tend to have a kind of one-way flow of information. So you put a release out there, but you don't get much data back on what people are actually doing with that. So each one of these can be attacked independently, and there's a logical ordering that we see in organizations when they're doing this adoption. So I'll take you through the logical ordering and show you where things what tends to happen first. So if you're doing continuous integration, that's a great thing, and we're assuming that you're on the call because you are doing continuous integration. But the next step that usually, beyond just doing the basic build and doing some unit testing, you've got to get out of that build environment. And so having automated environment management where you can create a new test environment that looks like the production environment, that's provisioned the same way as the production environment with the same settings, ends up being really important. And in many organizations, this is a very manual process, and that forces them to either share test environments or reuse test environments. and those test environments may not, therefore, be clean. And so as a result, this wait time that gets introduced with the environments not being available ends up causing lots of delays in the process. And so by automating those environments, we often encounter this term of infrastructure as art. And to just summarize it quickly, what infrastructure as art means is that every single environment is unique. It's manually configured. It's not standardized. It's, in a sense, a work of art in the sense that, you know, it requires an individual to be creative about how they put things together. And it results in a problem that many of you have probably seen, where somebody gets a defect or you see a production incident, you bring it into the testing environment, and it works fine. You can't isolate the problem because it works fine in the testing environment. What that means usually is that the test environment is differing from the production environment in some critical way, and usually in some way that's not easy to see. And so as a response to that, organizations have gone to a technique called infrastructure as code. So all of those configuration changes that get made to environments, basically they're largely changes to files, or they're information that you could put into a script and run, and the script can do the same thing that a human would do when they're configuring the environment. And so that information gets versioned just like it's code. It gets run through various kinds of deployment automation mechanisms that, in effect, work like a build process, and combined with test data management and service virtualization, it allows you to completely simulate a production environment in testing with usually a fraction of the resources. So this automated environment management is something simple. You don't have to be an Agile project to do it. You don't actually have to do even continuous integration to do this. You could do it on legacy applications, and it eliminates a whole class of errors that occur quite frequently. So, but if you're doing CI already, you're going to need environments quickly. You're going to want to do something like this. So this is a really easy, you know, I often refer to this as the low-hanging fruit in continuous delivery, because, you know, it's relatively easy to do. It doesn't cause a lot of people to change the way that they work, and it actually frees up operations to do things that are more valuable. So the next step, because you've got these builds that need to be moved from a build environment to a test environment and then through these staged test environments, the next logical thing to do is to automate deployments. And many times these automated deployments are manual, the existing deployments are manual, requires somebody to go through and execute a bunch of commands, sometimes using a copy and paste kind of mechanism, but there are a lot of opportunities for failure in that. And so by automating deployments, again, it doesn't affect a lot of people. And many times when I talk to people about automating deployments, they're afraid to automate the deployments into production. But in reality, it reduces the risk a lot, because if you've automated the deployments between test environments already, and the test environments look exactly like production, then automating deployments into production, which is a later step, is actually a very low-risk activity, and it removes all those possibilities of manual error. So this becomes a kind of almost similar to automating environment management, a really simple thing that organizations can do. They can prove it out in the test environments and then use it in production environments. And again, it reduces errors, frees up ops people to do more proactive kind of fault prevention activities. So some of the benefits of that, we talked about this, reducing manual errors, increasing reliability, reducing cost. And this comment down at the bottom, we've found fairly typical in many organizations who do manual deployments, is that they've got, either lots of emails floating around, lots of spreadsheets floating around, and taking that information and consolidating it into a deployment script makes it a lot more repeatable, a lot more controllable, and more importantly, provides you with rollback capabilities in case something does go wrong, so it's easy to recover from these changes. So that's a really simple thing, again, to do. The next step, the step number 3, is something that occurs in modern applications, and the automating testing with APIs ends up being important because you want to automate as much as possible from that continuous delivery pipeline. And so when you do this, you need to have APIs to run against. You can't really effectively test in the delivery pipeline using using manual testing, of course, and you can't affect user interfaces. Often they don't exist yet. So switching to an API, a loosely coupled API structure, ends up being one of the keys. And this loose coupling also improves your composability. So by improving composability, it gives you the ability to replace different components and move these, and basically implement these components, change the components, deploy the components independently, which starts to reduce your size of deployments. When you can deploy components independently, then you can evolve different parts of the application at different speeds. And it also gives you a different way of developing software. So instead of developing a lot of custom code, you're pulling components together and integrating those components together. And that also gives you additional speed of delivery. So we're seeing these techniques showing up increasingly in certainly mobile and cloud applications, but increasingly even in mainframe applications. I had a conversation the other day with basically a chief architect for a large insurance company, and they had used these techniques to simplify some of their underwriting applications. So continuous testing benefits, increased consistency. You can test every single build. That eliminates delays. But one of the big things is it starts to reduce costs because manual testing is very expensive, and it gets more expensive the more testing you do. When you automate testing through APIs, it actually has economies of scale, and so you reduce the complexity and reduce the cost per test run, and you start getting economies of scale in testing, and that reduces your overall cost and improves quality. So step number 4 is once you've got all that test data, then the release decisions become a lot more simple. You simply look at the test data. Do you have adequate coverage? Are all the tests passing? Do the test environments match the production environments? If all those statements are true, then the release decision is pretty easy. And if it's a very small release, perhaps just changing one service or one component, then it becomes even easier. It's easy to roll back. It's easy to recover and revert back to a prior version. So release decisions become much simpler once you start automating these various aspects of the pipeline. So obviously it gives you increased confidence, fewer incidents, simplified release decisions, reduced risk. So reducing the release size then once you have a more modular application, you can start thinking about just changing a particular API or changing a particular service that changes the behavior of the applications. And one of the implications of that is that you want to think about these requirements that you're working on. The bigger the release, the more requirements you've got. And in those requirements, until you start showing things to customers, you don't really know whether the requirements are good or not. So as a result, basically, it's kind of like unsold inventory. Until you actually sell it, or until somebody uses it and tells you it's good, you don't know if it's useful or not. So what we've identified is that as organizations get their releases smaller and they're changing fewer things at a time, it not only improves the speed, but it improves the quality of feedback that they're getting, because they change a single variable, they see whether that improved the results. If it did, they do more of that. If it didn't, they do less of that. So one of the useful techniques that comes in here is that Agile ends up being an important part of this. Basically, Agile Sprint is a way of breaking down a large problem into smaller problems, and if you're doing the sprints right, then at the end of every sprint, you've got potentially releasable software. So we see Agile being a key component of reducing the batch size, as well as introducing some new teaming models. One of the things that you want to do in each release is that each release really needs to focus on changing an outcome for a particular set of users. So you can use things like personas out of user experience modeling, identify the different outcomes that are desired by different personas, and each release might target only one outcome for a particular persona, and that outcome for a particular persona, in effect, gives you this idea of this minimum viable product. It's the minimum amount of change that you can make to have it still be useful or still be viable to somebody. So now we start to get into some of the harder changes because they involve cultural changes, and eliminating handoffs and wait time is one of the key challenges that organizations have. And one of the reasons for this is that we've organized in a way in the past that doesn't really improve the flow in the organization. What the organization structures of today tend to have is that you've got various silos of expertise, and these various roles have to work together in order to produce a release. But generally speaking, every time you've got a role involved, you've got a handoff because people are involved in multiple different projects or multiple different activities. So many times when you need somebody to do something, they're not right there available to do it immediately. You've got to wait for that. So in the past, we've tried to maximize people's utilization, which has meant that if you're working on something all the time, the chances of somebody, when they need you, the chances of you being busy are pretty close to 100%. So the new goal in this new model is to try to maximize throughput, which means organizing differently. And so we take a page out of the Agile development playbook in a sense, and we organize teams so that they tend to be organized around products. And the difference between a project and a product is that a product is something that lives over a long period of time. You do multiple releases over a long period of time. You're not funding each release independently. They're not independent sort of projects, but rather you fund the product for, let's say, the budget period for the year. You dedicate a team to that, and you keep the team together through releases. So this is one of the enablers because you don't have to wait for funding approval or wait for project approval to start working on something. You're always working on work. The second thing is by keeping a cohesive team together, you don't have the team formation activities going on, and you've got ideally all the skills you need on that team to produce a good result, so you don't have to wait for resources. To keep those teams more cohesive across roles, then you've got things like communities of practice that then let developers share all of their experiences within their community, let QA share things within their community. So you're using communities of practice as an informal way of connecting people together instead of using organizational silos to do that. And the managers tend to work in a different way, like a manager in a manufacturing plant. They're not telling people what to do on a daily basis, but rather when there are breakdowns in the process, they're helping that team to, in the manufacturing example, get a machine back online or get a shipment, find out where a shipment is and get that accelerated. So a manager in the modern organization structure is more of a problem solver and a barrier remover than somebody who's directing people on a daily basis. So that, once we can start doing this thing, any kind of speed up in the cycle gives us better feedback, and that better feedback then leads to better results because we're building less of the wrong thing, we're building more of the right thing, and we're getting that feedback relatively quickly. So as we move through that, then the teams feel more connected to customers. They start to understand the customer better just directly. And so we've talked to many organizations who've done this, and when they deliver it relatively fast cycles, oftentimes the developers have great ideas about what it might improve customer satisfaction. And it's not some subject matter expert giving the team requirements and then they go implement it. It's everybody really seeing a better picture of what the customer wants and being able to act on that more rapidly. So just in summary, if you're already doing continuous integration, great. That's a great place to start. By itself, though, it usually needs more things because what happens when you just continuous integration and all those other bottlenecks in place is that you then struggle with many of the problems that I was describing. So improving those bottlenecks often starts with technology, but gradually migrates more into the processes and the people and the way the organization is structured. Usually that journey begins with a more change in leadership and a realization that the organization as a whole has to work differently. But when the organization starts to move in that direction and starts to get to fast release cycles, we've seen that organizations have really dramatically different results. And it's not just in the financial and the business results, but it's also just in the way that people feel about what they're doing and how connected they feel to their work is connected to the value that they produce. So with that, I'm going to turn things over to Dan, and he's going to talk about some how you can do these things with Jenkins.
All right. Excuse me. Thank you, Kurt. That was really interesting stuff. I think really good guidance for a lot of our audience members to really get their head around how to do continuous delivery and what the benefits are for them. As you said, I want to talk a little bit about the technology that we are focused on here at CloudBees, and that's Jenkins, and how you can really move from CI to CD using Jenkins as your platform for doing that. And how you can also address a lot of the steps that Kurt outlined as the prerequisites for achieving it. So as Kurt said, continuous delivery is really all about applying automation to the application lifecycle, right? You've got developers writing code. You want to get that code to your end users, your customers in the running production application. And so it has to go through a bunch of stages. The developers commit the code. You need to build the application. You need to do the testing. As Kurt managed, you need to do deployments. And if you are able to apply automation to all of this and then orchestrate this whole process, this whole pipeline, then you can really achieve continuous delivery. Of course, a big key aspect of it is the feedback loop that Kurt mentioned, getting the feedback back to the developers and to the operations folks. So continuous integration is really about applying automation to the front end of this process. As Kurt said, it's been around for a while. We're seeing pretty wide adoption of continuous integration, especially for new greenfield projects. It really does help and kind of accelerate the initial phase of the pipeline by automating the build and then automating testing, whether it's unit testing or functional testing or user acceptance testing. CD then applies that automation across the rest of the lifecycle, extends it, if you will, across the full lifecycle. And so you're able to continue to do the build and test automation, but then you roll in deployment automation for deploying into staging environments where maybe you're running more testing, and then ultimately to deploy to production if you want to do that. So some of the aspects of continuous delivery, though, that become important as you think about this is becoming a mission critical pipeline, right? This is how you're getting your application delivered to your customers. So you really need to have an enterprise grade platform to run this whole continuous delivery management. Of something that can orchestrate the whole end-to-end pipeline. Also you need complex delivery pipelines. Real-world application pipelines are complex. They may have branching and forking and loops, restarts, and that kind of thing. So you need something that can handle that aspect of the continuous delivery pipeline management. And then, as Kurt mentioned, it's not just about the application code or the source code. You need to automate the environment provisioning as well, the configuration. So you need to deliver the application's environmental configuration with the application when you go to production. So we've talked about pipelines. Kurt mentioned pipelines a couple of times. Pipelines are really the essence of continuous delivery, right? It's the pipeline of the piece of code that gets contributed by the developer. When it gets checked into the source code control system, the continuous delivery management platform will grab the code and run it through the pipeline. And as Kurt said, you might have a bunch of small pieces of code being checked in. So small features, you're developing your code in more of an agile bite-sized approach. And so you'll have a bunch of these pipelines running maybe concurrently. You, of course, need to execute those pipelines to be able to orchestrate the actual tools that are going to run each stage of the pipeline. But you also need to monitor and provide the feedback, understand how the pipeline's running, understand what's going on with the code. Are the builds working? Are the tests failing? Are they running? Or are they working? Every stage will have its own results. And as Kurt said, both CI and CD really extend this notion of agile software development, which is all about small incremental changes that are made available continuously and delivered. And by doing that, you get fast feature delivery, you get lower risk of failure, lower error rate in production, and ultimately happier customers or business users or end users, whoever your target audience is. So where does Jenkins come in? Well, Jenkins is an open source project that was first initially developed for continuous integration. It's been around for over 10 years and is very widely used for continuous integration, very popular tool. It's easy to use and very powerful, and a lot of people are using it. Jenkins is also now your key to continuous delivery. So the Jenkins Workflow is a plugin that does continuous delivery management, and it's available, for the Jenkins. It works as a plugin. You can install it, and then you can really extend your continuous integration work into full continuous delivery. So with Jenkins Workflow, you can do the code scans, the application builds, the testing, and also move into deployment, into staging, or deployment into production. It's got the capability to handle very complex real-world pipelines, and it can now handle working with environmental configurations, and we'll talk more about that in a second. One of the cool things about Jenkins is that it's a plugin-based architecture, and so this allows it to integrate with a whole variety of DevOps tooling that's out there. So Jenkins you can think of as the master orchestrator, right? It's orchestrating the continuous delivery pipeline, managing the whole process, and it's calling out to best-of-breed tools to do the different functions that need to happen, whether it's Maven for doing application builds, Selenium for testing, whatever it is, testing tools, deployment tools, release automation tools, user acceptance tools. Jenkins has over 1,000 plugins for integrating with these tools. And so in essence, Jenkins really can be thought of as the hub of the continuous delivery ecosystem. So integrating with source code control systems like Git, Jenkins can understand what the developers are doing and provide traceability back to an individual developer, integrating with the testing tools, integrating with the configuration management and deployment tools such as Puppet and Chef, and some of the deployment tools from NCA and Midvision, and then integrating with the deployment targets, the deployment platforms. So whether they're cloud-based platforms like Amazon Web Services or Microsoft Azure, or private PaaS platforms like Pivot or Red Hat's OpenShift, or infrastructure as a service such as OpenStack, or even on-premise application servers like JBoss and WebSphere or Microsoft.net. There's plugins and interfaces to allow Jenkins to deploy your ultimate application product into any of these environments. So it really gives you the power to, no matter what tools you use in-house, to orchestrate your CD pipelines and manage them and run them. Jenkins Workflow has very complex and robust capabilities around managing pipelines. It allows you to create pipelines that do things like branching and looping and restarts. It allows you to have manual intervention checkpoints, so you can, maybe you don't want to automatically deploy to production. Maybe you want to get everything ready to be production ready and ready to deploy, but you want someone, a human, to give it a final look and then push the button for deployment. So Jenkins Workflow is a very powerful capability that allows you to do all this built on the robust Jenkins engine, that's been around for 10 years and is well known and is easy to use. One of the visualization aspects in terms of monitoring the pipelines is the CloudBees Jenkins Workflow Stage View plugin, which gives you a visualization of every pipeline that's running and shows you whether it's been successful, what stage it's at, et cetera. So again, giving that feedback to the developers and to the operations teams so that they can understand how things are working and where they are in the stage. So let's talk a little bit about something that's also top of mind these days, and that's Linux containers. So it's really, containers have taken off in the past year and a half or so, really driven by the movement around Docker, which is probably the most popular Linux container format today. What Linux containers do is allow you to really isolate an application and its environmental operating system configuration encapsulate it into a container. And a bunch of different containers can run on the same host operating system, but they can have their own environmental configuration defined in the container. So that's really cool, but how do you do CD with Docker containers? Maybe you want to take advantage of containers to encapsulate this operating system configuration information so that you have the exact same information in dev, QA, staging, and prod, exact same operating system configuration that the application wants to run it, right? So containers have a ton of promise and look very, very cool for being able to manage this configuration and automate the deployment of configurations this way. Well, there's 6 new Jenkins plugins from working with Docker. One of the most interesting ones is the Docker Workflow plugin, which allows the Jenkins Workflow CD pipeline management system to work with and manage containerized applications. So now when developers check in code, they can check it in and it can be built into a Docker container, and then that Docker container can be pushed through the lifecycle of the pipeline. So there's a number of other plugins here. There's plugins to integrate with the Docker Hub, so the container repository. There's plugins to be notified, so that Jenkins can be notified when the Docker Hub trigger happens. So when someone checks in a container or checks in a change to a container that's downstream of the application, Jenkins can know about that and then rerun any pipelines that are needed. There's also Docker traceability. So if an operations team member changes a container configuration and that ends up impacting the application in production, you can trace back and see what happened and who did it. And there's also the ability to run Jenkins slave build servers in Docker containers. So it's very useful and kind of low-hanging fruit use case is to just use Docker containers to run your Jenkins slaves. So if you think about this now, we have our application code being written by the developer checked into the source code control system. Jenkins will grab that and run it through the pipeline. But now you also may have the container configuration, which is checked into Docker Hub. And so now either of these can be a trigger for a rerun of the pipeline, for a rebuild of the application, right? So when the operations team member changes the Docker image, then that would kick off Jenkins to rerun the pipeline and redeploy the application. So you have two triggers now. One is the environmental information defined in the container, and the other is the application code, which is the traditional way of thinking about continuous delivery. So a very cool way to encapsulate your configuration information and do that automatic provisioning of the environmental information that Kirk talked about. So if you think about this, the workflow continuous delivery pipeline can now be triggered by either environmental change or an application code change. That would trigger Jenkins to rebuild the application in its container, create essentially the gold master image of the new version of the application, and then run that through your staging, your testing, staging, and production parts of the lifecycle. So again, really fully implementing continuous delivery for both environment and application code, and automating everything so that you're reducing error, you're accelerating the process, and reducing risk as well. Interesting as a side note, Docker Inc., the company behind Docker, in fact uses Jenkins to test Docker itself. They dog food their own technology. They test Docker with Docker, but for continuous integration, continuous delivery, they use Jenkins because, as they said, they need a lot of flexibility and control, and Jenkins gives them that with its open and plugin-based architecture. Kubernetes is another really interesting new technology that's come out for managing and orchestrating containers at massive scale. So if you have an application made up of 100 different Docker containers, how do you manage that? How do you deploy it? And how do you keep it running? Kubernetes was built by Google and is now an open source project that's designed to do just that, manage very large clusters of containerized applications. And so the Jenkins plugins that we have for Docker also work in a Kubernetes environment, and we have a plugin specifically for Kubernetes to allow you to run Jenkins slaves elastically in a Kubernetes cluster. So again, really interesting technology, changes that are happening very quickly these days. We believe that containers, continuous delivery, and microservices-based applications, composable applications, as Kirk described, are really on the forefront of driving some real cool innovation. Jenkins is, as I said, very popular and very widely used. There's over 100,000 active installations of Jenkins out there that we know of, and there's millions of jobs that are run that have been running Jenkins worldwide. This chart, shows a very interesting kind of hockey stick chart of the growth of the number of jobs that are running within Jenkins. So Jenkins is, clearly has a lot of value. A lot of you are probably using Jenkins in your environment, but you really want to, move to enterprise scale with your Jenkins usage and move to continuous delivery. And so you need to be a mission critical part of your platform. Well, CloudBees is the enterprise Jenkins company. We're the company behind Jenkins, and we provide a commercial product called the CloudBees Jenkins platform, which really is designed to do just that. It allows enterprise scale usage of Jenkins for continuous delivery. Our goal is to really help people help organizations develop and deliver better software faster. In today's world, it's an application economy. Every business needs to be in the software business, as they say, and so we view the technologies we provide as something that can really help with that continuous delivery solutions, powered by the power of Jenkins underneath. So our subscription offerings are the cloud-based Jenkins platform for on-premise use or in the cloud as well. And then we have a SaaS offering as well called DevOps Cloud. The cloud-based Jenkins platform is a very robust implementation of Jenkins. It includes the Jenkins open source core software, of course, but then we provide a couple things. We provide advanced enterprise features on top of the core open source project. So enterprise features along the lines of things that you need and expect in enterprise class software. High availability for your Jenkins servers. Performance optimization so they can run as optimally as they can. Enterprise security integrations, role-based access control, integration with your LDAP systems, integration with other platforms such as vSphere, Amazon Web Services, and then specific features for managing teams and making it easier to allow different teams to work within Jenkins and get that visibility into only the aspects of it that they need. So team management, developer productivity, specific features around integrating with Git and GitHub. One feature called validated merge, which allows you to validate that a Git check-in that the build will be successful before you check it into the master trunk. So very, very popular and powerful feature. So again, cloud-based Jenkins platform is the open source technology. Layered upon that are some advanced enterprise features. Also, of course, comes with full technical support as well. Cloud-based also provides professional services around Jenkins, training, security advisories, newsletters, etc. So just kind of to summarize, we view this as really turning what in many organizations is kind of an application delivery chaos, right? It's very confusing and crazy. If you've read the Phoenix Project, the book by Gene Kim, they have kind of the quintessential application delivery chaos at the beginning of the book, right? But then turning that into an automated application assembly line. So you're automating the process, you're applying lean manufacturing principles, as Kirk discussed, to really kind of increase the workflow, increase the flow of your application code to production so that you can get features out to your customers and meet your business needs. If you want to learn more about continuous delivery and meet Kirk Bittner and in fact myself in person, please join us at our Continuous Delivery Summit, which will be September 2nd and 3rd in Santa Clara at the Santa Clara Convention Center. Gene Kim will be there, Kirk Bittner will be there, and we'll have continuous delivery experts, real users and real customers talking about their continuous delivery implementations. In fact, the conference is going to be in conjunction with the Jenkins User Conference, which will also be in Santa Clara, September 2nd and 3rd. The Jenkins User Conference is a two-day conference where you can really get into the nuts and bolts of Jenkins, learn from key practitioners, learn from the key developers, learn from the founder and creator of Jenkins, Kosuke Kawaguchi, and get some real insight into how you can leverage Jenkins, talk to a number of other customers about what they're doing, and really get your arms around in Jenkins and continuous delivery. So with that, I think we will wrap up the content and then jump out to some Q&A. All right. Let me pull up the Q&A panel here and take a look at some of the questions we have. Okay, Kurt, here's a question for you from Clay. How do you think containers will change the CD tooling market?
Well, so in some ways it simplifies it, and in other ways it makes it more complicated. So where it simplifies it is that it means that a lot of the environment management and configuration becomes a lot easier. What you're doing is configuring a container, which is smaller, simpler, easier than configuring a full virtual machine or a full physical machine. Where it gets more complicated is that now when your application is spread out over lots of different containers, it means that you've got a lot more things running in production that you now have to gather feedback from. And so a lot of that runtime management aspect of containers we're really just starting to explore now. But if you think about continuous delivery as not a one-way pipeline, but really a feedback loop, then it'll simplify things in one part of the pipeline, but make it more complicated to work in other parts of the pipeline, especially the information gathering and analytics parts.
Okay, great. Here's a question that I will take. We use Jenkins to deploy our applications. Is this the best approach? Should we use CM tools like Chef or Ansible to manage the app deployments? So I think our answer is that really comes down to what's best suited for your environment. Jenkins is certainly quite capable of doing the application deployments. The CM tools are really more about, in my view at least, really more about configuration management in terms of making sure that your environment, your operating system environment, is the same for the application when you deploy it from dev to test to stage to production, right? So Chef and Puppet and Ansible, they can help make sure that all the settings are being set correctly in the environment for those application deployments. But again, one of the cool things about Jenkins is that it's very robust and powerful itself. It also has the plugins and interfaces to a bunch of other technologies. So it really kind of you can pick and choose the tools that you want to use in your world. Quick question around will the PowerPoint be shared in PDF format? Yes, we will be sending out both the slides as well as a link to the recording so that you can share with your colleagues if you want to. All right. Here's a question for you, Kurt. What is the best approach to move legacy apps to continuous delivery?
Well, it's a longer path for many organizations. The simplest thing to do, and the things that you should definitely do, are to automate the environment management, so automate the provisioning and testing environments, and automate the management of production environments. That's certainly a big part of continuous delivery. The other part that will help is to automate the deployment of the application. So take the manual activities out and automate those, start scripting them, and then gradually collect them together into a fuller deployment automation. So that'll give you rollback capabilities that will take a lot of the risk and concern out of it. Over time, the bigger problem with legacy applications is that they're not loosely coupled, so they tend to be relatively monolithic and relatively complex. And so what we've seen is that organizations are now undertaking multi-year and somewhat opportunistic sort of transformations of those legacy applications. So perhaps replacing hard-coded COBOL rules with a rules engine is one example, or using services to implement the application when you're adding new functionality or changing functionality. So migrating code out of the old monolithic COBOL base into modular services is really the transition step. And as you do that, you can certainly use continuous integration tools to do the build and deploys to testing environments and start running unit tests and other sorts of tests. So I'd say it's a longer incremental process because of those architectural barriers, but all of the same principles that we talked about apply to legacy apps as well.
Okay, great. Here's a question that came in. What is the difference between what CloudBees offers and the open source Jenkins? So as I mentioned, CloudBees Jenkins platform includes the open source project code, the open source technology, specifically the long-term support release, which is comes out about quarterly. But it also adds on top of that additional features delivered via plugins. And so these features give you kind of more advanced enterprise capabilities. Some of the features are embedded in a component of it called the Jenkins Operations Center. And this is really a manager of managers for Jenkins, if you will. It gives you a dashboard so you can see all of your Jenkins environment, all your different Jenkins master servers running, and get a complete overview of the performance and how things are running across your whole Jenkins environment. You can also do some really cool stuff like share slave servers amongst different Jenkins masters. So if you're running multiple Jenkins masters, then you can really manage them much more effectively and scale out your Jenkins usage much more easily. So again, there's a bunch of enterprise features that are identified on our website that come above and beyond the open source project and allow you to really leverage Jenkins at enterprise scale and get the most out of Jenkins for your different teams that may want to use it. All right. All right, Kurt, here's one I'll throw over to you. I work on a development team and operations control the environment in our organization. How can we get them to work with us to automate the environment availability?
Well, this is where it helps to have that executive leadership, and without it, you generally run into a wall. But let's say that you don't have executive leadership and you can't basically have some leader come together, maybe with the leader of ops and the leader of dev and say, hey, we really all need to work together. If you don't have that, you can still, basically try to reach out to the ops people, really understand their concerns, just establish a dialogue. So, start to build trust, or at least open communication is a good start. Some organizations help to do that by putting developers on calls so that the ops people see that the developers are getting an understanding of what's happening in ops to build that. But basically, once you've got a dialogue with the ops people, just share with them some of the things that are happening, around environment management, automating things, and how it can help. They may not have the development and scripting skills that you have as a developer, so helping them do some of that automation, just pitching together and working together goes a long way. So it's a combination of some top-down encouragement and just sort of a peer-to-peer networking, really trying to build bridges instead of throwing things over the wall at one another, is the way that many organizations have done it in the past. So those are the strategies we've seen working in many organizations.
Okay, cool. All right, good. Well, I think we're at the top of the hour, so to be respectful of everyone's time, there were a couple of questions we didn't get to, but we will follow up on those via email. So I would like to thank everybody for attending, and I want to thank Kurt for a very insightful presentation. And again, if you'd like to learn more or hear more from Kurt, please join us at the Continuous Delivery Summit, September 2nd and 3rd in Santa Clara Convention Center, as part of the Jenkins User Conference World Tour. So with that, thank you all, and we look forward to hearing from you soon.